Hello everyone, welcome to this video where we're going to look at how we can use STimber's copy tool in order to create duplications of our geometry and our loads. And I'm going to do this with a very simple application. Let's just assume here for this example that we have a single column. I'm not going to worry about modifying any of the default parameters related to materials or sections. My goal is to just keep this as simple as possible. So I'm going to place this column at the origin of my coordinate system, which you'll see here is at the x equals 0, y equals 0, z equals 0 coordinate. So I click to place it here. I'm using a 3-meter high column, and what this does, if we look at the finite element model that's created behind the scenes, is it creates a joint at the point that I clicked on, x, y, and z equals 0. And if I left click on the top joint with the selection tool, I can see that it's created another joint at the top of the column, which is x and y equals 0 and z equals 3 meters. I can also apply a load to this just for the sake of an extra feature. So here I'm going to go ahead and say that I have a load of -5 kilonewtons just at the top of this column in the z-axis. So it's applying some compression. I'll also fix the bottom of this joint at the column base, so I'll make it fixed. And what I want to do is duplicate this particular setup here. So I'm going to go to the selection tool again that I was using earlier, and I'm going to left click and select this particular object. And I'm going to go to the edit menu now, and I see that I have this option to copy. So I can click on this copy command, and this will allow me to configure my copied objects to be either the selected objects only or all of the objects in my model. I want to have a little bit of precision control, so that's why I could control this if I had more than one object. I've also applied loads to this particular instance of my column, so I'm going to make sure I copy those as well. And then I can go ahead and define the copies. So I'm going to go with a copy of 2 meters, and I'm going to say that I have 2 copies in total. So I'll click OK. And you can see here that it's generated those copies. It's retained the support conditions. And if I were to look at the load selection tool, I can see that I do actually have those loads on top of my columns as well, 5 kilonewtons. Now if we wanted to modify these locations at all, we could do that as well. So I could go to the physical element view, which is going to show me basically all the different joints that would normally go into characterizing this column. And if I select this whole column in the middle here, it's going to select not only the joints, but the members along with it as well. But the member will always be drawn between those joints. So I could click on the joints field here, and I could notice that I actually have this coordinates for the locations, where the y coordinate is shared between both sets of joints I've selected. We have this value of 2 meters, but they actually have a different z elevation, z coordinate, that's between 0 and 3 meters. So it's giving me this question mark just because the two values don't match. If I wanted to move this, I could simply just type the new location here. I could go to, let's say, 3 meters in the y-axis, and it's going to move it there right away. If I want to move it back, I go to the 2-meter option and move it back. Another option that I have available to me is to go to the edit menu and go to move. And you can see here we can actually control this not so much with the coordinates, but just with the general distance that we want to move something with. So I can say I want to move this in the x-axis 1 meter away, and I left click there to apply it, and we've moved those objects around. Another handy feature that's available in STimber is the command history window. And if I just open that window up now and go to the window layout and say I want to open the command history window, what this has done is it's generated for me basically a number of different lists, or a number of different transactions that are listed here in order. So I first of all created a new file. Then I inserted joints into my model. 2 joints because I created a column that had a joint at the top and the bottom. I also had some additional members added as we went along. And you can see here that we made some adjustments to the different joint locations and so on. I'm not going to go into too much detail, but I do want to right click on this and see the options that are available to me. You can see that there's this export script option. And if I go to export script, it's going to generate for me a Python script. And I'm going to save this here. And without typing a single line of code, I have this Python script that is showing me basically all the different transactions and how they can be accomplished through the API. So we've exposed these different commands through the API simply by performing that task in the interface and then exporting that script at a later time. So that helps us learn our way around the API. And if we just look at this, each command or each transaction is separated into its own section of this code. So command number 1, which is this one here, is to open up a new file with a Canadian template. Command number 2 was a collection of different commands that, see, I started with some joints that I added to my model. I have those locations here that we're showing. We have the different degrees of freedom that we'll adjust later on. And a member in between that with quite a bit of properties behind that for different design properties, section properties, material properties, and more. And you'll notice that when we started copying and so on, it generated additional details related to our command that we can, again, override or adjust at any one point. So for this particular example, we can see here that it's generated a variety of different joints at different locations. I could go through and modify those. So let me just scroll to the bottom and find that last command that I performed, where we can see that we moved some of these joints around. So let me just say here that for the sake of this joint, number 4 that we moved around, I'm going to change the x coordinate to x equals 2, just for this one single joint. And I'm going to click play to run this script. It's going to ask me to save, so I'm going to give it a name here. I'll just call this test script. And you'll notice here that when the script has been run, we end up with a similar looking layout of that geometry that we had before, with the exception now that I modified the location of that one joint at the top of this column here. So this column is now located at x equals 2 meters instead of x equals 1 meter because of that input change I made in the script editor, where I changed that value to what we can see here. I believe this is the one here, joint number 4. So we can make modifications through the interface, as well as through the spreadsheet window, which I haven't really gone into detail yet. We can see here the different joint locations, and we can actually filter based off of the objects that are selected if we wanted to make that type of modification. And of course through the scripting environment as well. So there's quite a few different ways that we can accomplish this task depending on what it is that we need to do.